Hello, everyone. Now I will introduce to you how to achieve Modbus communication through the second serial port on the DB9 of Huceen E7 CPU. The DB9 pin on the E7 CPU integrates two RS485 communication interfaces. Among them, pins 3 and 8 are the first RS485 interface, and pins 4 and 9 are the second RS485 interface. Taking the communication between the second RS485 interface on the E7 CPU body port and the frequency converter to control the operation of the frequency converter, adjust the speed, and read the output voltage value of the frequency converter during operation. As an example, I will explain how to use this RS485 interface. The fourth pin of the second RS485 interface on the E7 CPU body port is the positive of RS485, and the ninth pin is the negative of RS485. The positive of RS485 is connected to the fourth pin, SG positive, of the communication port on the frequency converter, and the negative of RS485 is connected to the third pin, SG negative, of the communication port on the frequency converter. A DB9 male connector is required for connection on the CPU side. First, the Modbus library instructions provided in Step 7 MicroWinSmart software support the first RS485 interface on the DB9 port of the body and the communication board extended above the CPU. The second RS485 interface on the DB9 port of the body requires the use of the Modbus library instructions provided by Huceen. HC Modbus RTU Master 3 volts 1.1 is the master station library, and HC Modbus RTU Slave 3 volts 1.2 is the slave station library. Second, right-click on the library, select Open Library File, then copy and paste the two Modbus library instructions into this folder and close it. Right-click on the library and select Refresh Library, and the added Modbus library instructions will appear in the instruction library. After setting the communication parameters of the frequency converter according to the frequency converter manual, call the added Modbus library instructions and write the PLC communication program. Program Segment 1, the initial port instruction MBUS_Control 3 is called to initialize the port. The parameters of the instruction are filled in combination with the parameters of the frequency converter. The enable bit of the done position of the MBUS_Control 3 instruction enables the first MBUSM_MSG3 instruction. Program Segment 2, the MBUSM_MSG3 instruction is called to control the operation commands of the frequency converter. After the execution of this instruction, the enable condition of the instruction is reset using the done bit on the instruction, and the enable bit of the next MBUSM_MSG3 instruction is set. Program Segment 3, again invoke the MBUSM_MSG3 instruction to set the speed of the inverter. After this instruction is executed, use the done bit on the instruction to reset the enabling condition of the instruction and set the enabling bit of the next MBUSM_MSG3 instruction. Program Segment 4, again invoke the MBUSM_MSG3 instruction to read the output voltage of the inverter. After the execution of this instruction is completed, use the done bit on the instruction to reset the enabling condition of the instruction and set the enabling bit of the first MBUSM_MSG3 instruction to enable it to execute in a loop. First, download the compiled program to the CPU. After downloading the program to the CPU, use the status icon to monitor the VW100, VW110, and VW120 addresses. Among them, VW100 is the operation command address. The operation commands are 16#0001 stop, 16#0012 forward operation, 16#0022 reverse operation. VW110 is the set frequency address with a frequency resolution of 0.01 Hz. If the given value is 3000, the set frequency is 30 Hz. VW120 is the output voltage value with a resolution of 0.1 volts. If the value is 800, the output voltage is 80 volts. Parameter modification instructions. Modify the value of VW110 to 2000, indicating a set frequency of 20 Hz. After the instruction is executed, this frequency will be written to the frequency converter. Modify the value of VW100 to 16#18, giving the frequency converter a forward operation command. At this time, the frequency converter operates forward, and the current output voltage value of the frequency converter is displayed in VW120 as 901, indicating a current output voltage of 90.1 volts. Modify the value of VW110 to 3000, indicating a set frequency of 30 Hz. At this time, the current output voltage value of the frequency converter is displayed in VW120 as 1330, indicating a current output voltage of 133.0 volts. Modify the value of VW100 to 1, and the frequency converter stops operating. The output voltage value in VW120 becomes 0. The above is the usage introduction of achieving Modbus communication through the second serial port on the DB9 of Huceen E7 CPU. Thank you all for watching.